This video is going to go through Cartesian graphs, what a line on a Cartesian graph represents, and how we can check to see if a point lies on a line. Alright, so on Desmos here, I've got myself a graph. Down the bottom, I have a number line. The number line is going to represent something. In this case, it's going to be the number of conversions scored in a game. So on this number line, I can say how many conversions are scored. So if I want to say 4 conversions are scored, I put it here, 2 conversions, 7 conversions, whatever. Now I could also plot on how many points that earns you. Now because each conversion is worth 2 points, if I can score 1 conversion, that's 2 points, 4 conversions, 8 points. So I can plot both of those things on here. However, that gets a little bit confusing. So what we can do instead is we can put the number of points on a different number line. Okay, so 4 conversions, 8 points. I can represent both of these things at the same time. Now, you might be familiar with this. We can then plot this point on the grid by going, okay, well, where is the point that lines up with both 4 conversions being scored and 8 points being scored? And we can plot that point on there. So that point there represents 4 conversions being scored, the first number, and 8 points being given, the second number. Okay, what we can do is see what happens when I look at all of these pairs of points. So 1 conversion, 2 points, 2 conversions, 4 points, 3, 6, 4, 8, etc. You can see that these end up forming a straight line. In fact, I can plot that line on the graph. So when we are using a Cartesian graph like this, this line represents all of the points that are true for this particular scenario that I've described. Okay, so if I had something like this where I'd made 5 conversions and scored 3 points, that doesn't make any sense, and that's why it's not on the line. If I had made 2 conversions and scored 15 points, that also doesn't make sense. That's why it's not on the line. The only points that are going to be true are the points that are on the line. So when we draw a line on the Cartesian plane, it's the only points that are true for that particular scenario that we've described. Okay, what we want to do now is we want to be able to plot a linear relationship. So what we've got here is the function of x is equal to negative 3x plus 12. So you do negative 3 times whatever x is, and then you add 12 on the end. And we're just going to do that for the numbers from 0 to 4. So I've got my Cartesian plane over here. I'm going to graph the points from 0 to 4. So when x equals 0, the function is going to equal 12. When x equals 1, the function equals 9. 2 it's 6, 3 it's 3, and 4 it's 0. So these are all the values of the function when x is each of these numbers. What we can then do is we can plot these onto the plane. So again, when x is 0, the function is 12, or y is 12. When x is 1, y is 9, 2 and 6, 3 and 3, 4 and 0. Now, this is a linear relationship, which means it's a straight line. So linear means line. We can draw a straight line through those points. Now that we have this straight line, some key things we might want to know are what the x-intercept and y-intercept are. All that means is where does that line intercept the x-axis? So again, the x-axis is the one down the bottom here. It intercepts it at this point here. So when x is 4, it intercepts the axis, and for the y-intercept, we're going up here. When y is 12, it intercepts the y-axis. So x-intercept and y-intercept are just where the line intercepts the axes, and the straight line represents the equation of minus 3x plus 12. Every single point on this line satisfies that equation. So if you did negative 3 times 1.6 plus 12, you would get 7.2. Every single point on this line is true for this equation up here.